welcome to the deep dive. Today we're going straight into something pretty fundamental, I think, for anyone involved in learning or discovery: academic integrity and ethics.
Mm-hmm.
Think of this as, well, your quick but comprehensive guide to understanding why these principles really matter, especially in academic and research worlds.
Academic integrity and ethics. It gives us a really solid foundation.
Okay.
Covers, everything from the basic definitions to how these ideas play out in research, even with things like open source software.
Right. So our goal here is to unpack these concepts, which seem pretty interconnected, highlight the most important bits, and just make them really clear and hopefully memorable for you.
Sound good.
We'll start by looking at what academic integrity actually means, then move into ethical considerations, particularly in computer science, which has some specifics.
Yeah, it does.
After that, we'll touch on the ethics around open source licenses, then broader research ethics, look at integrity within the academic setting, the details of ethics in scientific research itself, and finally, get into publication ethics and the core principles of ethical research.
Yeah, quite a journey.
It is. So let's jump in. What exactly is academic integrity at its heart?
Well, in essence, academic integrity, as our source puts it, it kind of boils down to having a consistent moral compass in your academic life.
Okay.
It shows up in your attitudes, how you think, what you believe. It's really about being honest and accurate in your work,
Right.
about being incorruptible, having strong moral principles that's sometimes called probity, and respecting the rules, the established principles within the academic community. So it's, much bigger than just not cheating on a test.
Right. It sounds like it's woven into the very fabric of how academic work should even be approached.
Exactly. And the university has a big role here at sort of fostering an environment that encourages good faith. Well, by making sure individuals are transparent about, or ideally actively avoid, any situations where their personal interests might clash with their academic duties. Conflicts of interest, basically.
And here's something that really jumped out at me. The document talks about teachers as, well, constant role models, whether they realize it or not. That feels like a huge responsibility.
It really is. Anyone in an academic role is basically continuously setting an example through what they do. It's not enough to just talk about integrity. You have to demonstrate it concretely.
Yeah.
That's how you build a culture where these principles aren't just, dusty rules, but actually lived.
Okay, let's pivot slightly then to ethics and morality, specifically as they relate to computer science. The source mentions some very specific expectations there.
Yes, definitely. Academic morality in computer science has some pretty distinct aspects, particularly around testing and assessment, how that's done.
Like what?
Well, things like the careful creation of question banks, with answer options that directly reflect what's actually been taught. That's one. Then there's the need for algorithms that can generate equivalent test versions.
For fairness.
Exactly. Crucial for ensuring fairness if you have different groups taking tests at different times, for instance.
So it's really about building a fair and transparent assessment process right from the start.
Precisely. And then the whole testing process itself needs to be transparent.
Yeah.
Managed in a way that accurately measures what students know.
Okay.
This includes, maintaining the integrity of the test, accurately recording scores, having clear, well-defined thresholds for passing or failing. Everything's got to be above board, easy to understand.
And it's not just about how students are evaluated, is it? I think the document mentioned something about licensed software.
That's right, yeah.
Right.
Using properly licensed software is presented as, well, a fundamental piece of academic morality in computer science, especially when CS is applied in fields like economics. But really, it applies more broadly to all software used in university labs, development environments. It's about respecting intellectual property. Simple as that, really.
Which is, of course, a key ethical point across many fields. Okay, let's explore open source licenses. This area can sometimes feel a little murky. What are the key ethical things to keep in mind?
Well, the basic idea behind open source is pretty straightforward. Grant users the freedom to use the software, share it, even modify it, generally without worrying about paying royalties.
Sounds good.
It is, but the ethical dimension comes in when you realize these licenses aren't all the same. Not by a long shot. They have different terms dictating how you can ethically use and change the code.
So it's not just a free-for-all then?
Exactly, not at all. Take the Apache license, for example. It's very permissive, puts very few restrictions on how you reuse the code, which makes it highly compatible with other software. The MIT license is similar, quite hands-off. Then you have things like the GNU General Public License, the GPL. This one's interesting because it guarantees those 4 key freedoms. Run the software, study how it works, share it, and modify it. But often, GPL licenses come with something called copyleft provisions.
Copy left, right. What does that practically mean if I'm using GPL code?
Essentially, if you take GPL licensed code, change it, and then distribute your new version, you'll likely have to release your changes under the same GPL license. It's designed to keep the openness flowing, basically.
Got it. Keeps it open down the line.
Exactly. Then you have BSD licenses, another set of very permissive ones, minimal restrictions. The GNU Lesser General Public License, or LGPL, offers a bit more flexibility. It lets you use LGPL components in your own proprietary software without forcing you to open source your own code.
Ah, okay. That's a key difference.
It is. And finally, the Mozilla Public License, MPL, tries to strike a balance. You can integrate MPL license bits into other things, but those specific MPL components need to stay accessible under the MPL terms.
So the ethical choice involves really understanding the license you're dealing with and your own goals regarding openness. Okay, let's broaden the lens now to general ethical considerations in research, drawing on Bryman and Bell. This looks like a really comprehensive list.
It is, yeah. Bryman and Bell lay out 10 fundamental ethical points for researchers. It's quite a list.
Let's hear them.
Okay, number 1, avoid harm to participants. Absolutely crucial. 2, respect their dignity. 3, ensure full consent. 4, protect their privacy. 5, keep their data confidential. 6, guarantee anonymity where possible. 7, avoid deception or exaggeration about the research. 8, declare affiliations, funding, any conflicts of interest, transparency, again. 9, communicate honestly and clearly. And 10, present findings accurately. Avoid misleading or biased interpretations.
Wow, okay. Those all feel like absolute must-haves for responsible research.
They really are. And putting them into practice effectively means focusing on a few key areas. Voluntary participation is just paramount. People must never feel pressured to take part. And they absolutely must have the right to withdraw. At any stage. No penalty.
And informed consent.
Another cornerstone. Researchers have to give potential participants enough clear, understandable info about the study so they can make a truly informed decision. No coercion, no pressure.
And it goes beyond just getting that initial yes, doesn't it? It affects how you interact throughout.
Exactly right. It means avoiding any language in your materials, surveys, interview questions, whatever that could be offensive, discriminatory, or just inappropriate.
Okay.
Protecting privacy and ensuring anonymity are also vital, especially if you're dealing with sensitive topics. People won't open up otherwise.
Makes sense.
And through the whole process, from data collection to analysis to writing it up, maintaining the highest possible level of objectivity is just essential.
The document also stresses adhering to specific university ethics codes, right?
Yes, absolutely. Most universities have their own detailed codes of practice. Researchers must know and follow these. The source even links to the one at the Bucharest University of Economic Studies as an example. And beyond these big principles, ethical considerations also trickle down to, like, the technical side of academic work, using consistent terminology, following accepted rules for structuring texts, maintaining quality, making sure content meets academic standards.
Got it. Now let's zoom in specifically on integrity within the academic environment itself. Guerrero-Dib and colleagues were mentioned here, identifying 4 key elements.
That's right. They talk about justice, coherence, ethical principles, and appropriate motivation as the core parts of integrity.
Okay, justice, coherence, principles, motivation. How does that translate to academic integrity?
Well, building on that, they define academic integrity as acting with fairness and consistency, sticking to ethical principles, and being driven by good intentions.
Right.
In education, this means making it a habit to study and work academically with these principles in mind, motivated by, the genuine desire to learn and contribute positively. But they do note that interpretations can vary a bit.
So a shared core, but maybe some nuance depending on the context.
Precisely. Ultimately, though, academic integrity is seen as fundamental for high standards in teaching and learning. It demands responsibility, honesty, respect, trust, fairness, even courage.
Courage. How so?
Courage to do the right thing, to be honest about your work, even when tasks are difficult or you're under pressure. To avoid cheating or dishonesty, essentially.
That makes sense. Which leads us neatly into the specific area of ethics and integrity in academic scientific research. Sounds like there are unique pressures or characteristics here.
Yes. Scientific research, as the document highlights, often involves teamwork. It aims for original solutions, follows a specific cycle of activities. Validation of results is absolutely essential. It demands high levels of expertise and rigor. Reproducibility is key, and the goal is always accurate demonstrations.
Given all those moving parts and the high stakes, it seems like the potential for ethical missteps is significant if you're not careful.
Exactly. It's just vital for anyone going into research to really get a solid grounding in ethics, morality, integrity. Presenting work that isn't yours, or worse, faking results. The consequences can be severe.
For the individual and for science itself.
Absolutely. It damages trust across the board.
Okay, this brings us naturally to publication ethics, plagiarism, and the tools used to detect it. These are definitely hot topics.
They really are. And it's crucial to understand both plagiarism, using someone else's work without credit, and self-plagiarism, which is reusing your own published work without proper citation.
Right. You can plagiarize yourself.
You can. The goal, as the source states, should be extremely high originality in submitted work, like over 99% original according to anti-plagiarism software. That last 1% is usually just common phrases, non-essential stuff.
That is a very high bar.
It is. And the document warns against prioritizing speed, rushing to publish over the careful work needed to produce something genuinely original and valuable. Rushing is where plagiarism problems often start.
So how does the software fit in?
Well, anti-plagiarism software primarily detects copy-pasting. It calculates how much of the text consists of strings of words identical to sources found online.
And the document lists a few tools.
Yes, it provides links to several checkers: Papersol, Check Plagiarism, DupliChecker, PrePostCO, Search Engine Reports, and Plagiarism Detector. Gives researchers options for checking their work.
Good to know. The document also briefly mentions conflict of interest. This seems like something that could pop up in different ways.
Unfortunately, yes. Situations definitely arise where people have to make conscious choices to avoid conflicts, whether it's in their everyday work or in evaluation processes. Being aware of potential conflicts and handling them ethically is just part of maintaining integrity.
Okay, so finally, let's circle back and recap those core principles of ethical research, the practical, hands-on guidelines.
Right. The 5 key principles highlighted are: first, minimize the risk of harm to participants. That's number 1.
Got it.
Second, obtain informed consent. Third, protect anonymity and confidentiality. Fourth, avoid deceptive practices. And fifth, provide the right to withdraw.
And minimizing harm ties into the others.
Exactly. You often minimize harm by getting proper consent, ensuring confidentiality, being honest, and letting people leave if they want to. Informed consent, as we said, means voluntary participation, no coercion, no deception. Though there are very specific, limited cases where that might be slightly relaxed.
Right.
Well, maybe some forms of covert observation where knowing the research purpose would fundamentally change the behavior being studied. But those are exceptions requiring strong justification.
Okay, and confidentiality.
Crucial. Especially for sensitive info, it builds trust. Deception generally is a no-go, and that right to withdraw, it's absolute. At any stage, no questions asked, no pressure.
The document also threw in a couple of discussion points about co-authorship. These seem like real-world ethical dilemmas.
Yeah, they do. Like if someone gives a presentation for a colleague, does that warrant co-authorship? And what about group projects where contributions are really unequal? Should everyone still be listed as an author?
Tricky stuff.
Definitely. Things research teams need to discuss openly and ethically.
And so to wrap it all up, we've covered a lot of ground here, exploring this interconnected world of academic integrity and ethics. From the basic definitions to specifics in computer science and open source, the big picture of research ethics, integrity in academia and science, publication issues, and those core guiding principles.
Yeah, and I think the main takeaway really is that understanding and actually doing this stuff, upholding these principles, it isn't just some academic hoop jumping. It's absolutely essential for building and keeping trust.
Right. Trust within the academic world, the research community.
And for making sure that we advance knowledge responsibly and ethically.
Yeah.
It's fundamental.
So here's a final thought for you, the listener, to maybe mull over. With everything changing so fast digitally, with information and AI tools becoming so much more accessible, how might our actual understanding and practice of academic integrity and ethical research need to evolve? How do we keep these principles meaningful and effective going forward?
That's a big question.
It is. Definitely something we're thinking about. Thanks for diving deep with us today.